Shamrock 105 Heavy.
105, go.
Shamrock 105 Heavy, confirmed landing 22 left.
Affirm 22 left. Cafe taking Zulu Alpha.
Cafe 30 Heavy, turn to right, Zulu Alpha, right Yankee Alpha, door in Bravo.
Zulu Alpha, Yankee Alpha, door in Bravo, Cafe 830.
Heading 155, contacting your departure. Have a good day.
Have a good day, I 990.
1.9er, is the gates available?
Hotel short of Yankee and .9er. I'll let them know if the gate is available. 667. Runway 1 to right short, February 37. Kennedy Tower, zero Quebec Bravo is clear to the west.
Zero Quebec Bravo, 8 miles southwest of Kennedy Airport. Use caution, helicopter vicinity of Arizona Bridge. Radio service terminates. Squawk VFR, frequency change approved. Good day.
Squawk VFR, have a good day. Zero Quebec Bravo. Kennedy Tower, Delta 1's with you on the visual approach now to runway 22 left.
Delta 1 Heavy, Kennedy Tower, caution, wait turbulence, heavy just landed, runway 22 left, clear to land.
Land runway 22 left, Delta 1 Heavy.
Line out of below 500, caution, wait turbulence, all types overhead. There's also the opposite direction caravan, 600 feet, he's currently northwest bound.
Delta 4 cleared, 5 and below, eastbound, we'll be looking for the caravan, and caution the wake.
Shamrock 105 Heavy, turn right Juliet, taxi right on Zulu.
Right Juliet, right Zulu, Shamrock 105 Heavy.
Blue 684, turn right on Zulu Alpha or Delta Bravo if you have it. Blue 684, taxi right on Bravo.
Right on Bravo, we're going down now.
Direction the caravan is about 3 miles, 800 feet northwest.
Delta 4 has caravan in sight, keeping a visual caution.
Thanks. 37 Heavy Boeing 767 touchdown, runway 22 left, runway 92 tax, wind 210 at 11, gas 16, runway 13 right short and clear for takeoff.
Clear for takeoff, 13 right short,
Shamrock 105 Heavy, turn left hotel, runway 22 right.
Left hotel, 22 right, Shamrock 105.
On 2600, 123.9.
Kennedy Tower, good afternoon, Korean 249 Heavy, runway 10 Lima, Bill.
Korean 249er Heavy, Kennedy Tower, runway 12 left, clear to land.
President, runway 13 left, Korean 249 Heavy.
Delta 1 Heavy, turn right Juliet, right Zulu.
Right Juliet, right Zulu, Delta 1 Heavy.
Shamrock 105 Heavy, contact ground 121.9.
Ground point 9, thanks for your help, Mike.
Runway 37, turn right heading 170, contact air departure, have a good day.
Departure is runway 37, good morning.
Delta 2600, wind 210 at 11, gust 16, runway 13 right short and clear for takeoff.
Just made that 13 right short, Delta 2600.
Delta 1 Heavy, taxi by hotel, cross runway 22 right, taxi left south and monitor ground 121.9.
Hotel, clear to cross, 22 right, left on Alpha, ground point 9, Kilo Fox Century, Delta 1, good day.
Telegraph, Mike 45 Heavy, 22 left.
American 45, Heavy Kennedy Tower, wind at 210 at 11, gust 16, runway 22 left, clear to land.
45, Heavy, clear to land, 22 left.
Delta 2600, show my heading 170, contact us, departure, have a good day.
Right, heading 170, departure so long, Delta 2600. How about IMC 532?
NSC 5322, Heavy Kennedy Tower, caution weight 7, calling Heavy 747, now over Canarsie, wind 210 at 11, gust 16, runway 13 left, clear to land.
Runway 13 left, get to land IMC 532.
Niner Heavy Kennedy Tower, runway 13 right, short in, line up and wait.
13 right, short in, line up and wait, only 4, 9 Heavy.
Have a good day.
185 switching. You guys have a good day. JetBlue 351. Hello, good afternoon. You're Bluetooth 10 on the RNAV RMP 13 left.
Jared 12, gas 16, and I 13 right shorting, clear for takeoff. Flight 4008, Academy Tower, and I 13 right shorting, line up and wait.
Thank you.
34234,
This is Omega
155,
Tau,
contact
Science and Engineering in your headphones. Detailed conversations with people who know something. Visit omegataupodcast.net for all previous episodes, contact to the team, and general information about the show. Hello, welcome to another episode of Omega Tau. I don't even have anything to announce in addition to the episode itself, so let's get right to it. I'm talking with John Hutchinson about flying the Concorde, and here we go.
Okay, well, my name's John Hutchinson, and I started my flying career in the Royal Air Force in 1955. I did my flying training in Canada on an airplane called the Harvard in Moose Jaw in Canada, in Saskatchewan. And I went on from Moose Jaw to Gimli to fly T-33s. Came back with my wings in 1956 to England and went to fly Vampires in Worksop in the the Midlands really, I suppose, of England. And I was hoping to go on to Hunters, but at that point, a British politician called Duncan Sand said that there was not going to be any requirement for fighter pilots anymore. And none of my course went on to fighters. I ended up flying the Avro Shackleton, a maritime patrol aircraft, direct descendant of the Lancaster, the famous Lancaster aircraft. And I flew the original Mark I version of the Shackleton with a tail wheel. So it was a big four-engined tail dragger with four Rolls-Royce Griffon engines. Very, very fine airplane. And then I went to the Central Flying School to become a flying instructor and spent 3 years instructing at a place called Syerston, which is near Nottingham. And that was great. You know, I had a wonderful time there. And then I decided I needed to leave the Air Force because I thought I want to go on flying. I don't want to go flying desks in Whitehall or anything like that. So I left the Royal Air Force and I spent 3 years flying corporate aircraft, which ranged from the Helio Courier at one end of the scale, which is a short takeoff and landing airplane. Mm-hmm. It was used by the Americans in Vietnam. It took off in about, I don't know, 100 feet of runway or something. By the time you'd open the throttles up, you were airborne. It was a great airplane for short field work. And I used to fly jockeys and owners and trainers to race meetings, horse racing meetings all over the country here. Then also I was flying Piper Aztecs, Cessna 310s, Piaggio 166s, and doing air tests on a whole variety of small single and twin-engined aircraft. And I also got a helicopter license at that stage. And then in 1966, the airlines started recruiting again, and I applied to Qantas, BEA and BOAC. I was offered jobs with all three. I would have gone to Qantas, I think, out of choice, if my mother hadn't been dying of cancer. and I didn't feel it was appropriate to go to Australia at this point. And then I was left with the choice of BEA or BOAC, and I thought, well, I want to fly all around the world, not just around Europe. And so I joined BOAC, and I went on to the Boeing 707, and much to my shock, I discovered the first thing they wanted me to do was to become a flight navigator.
Oh.
Which almost is incomprehensible now with GPS and inertial navigation systems. In those days, on a Boeing 707, the way you navigated was using things like LORAN, long-range aid to navigation, Decker. Well, we didn't have Decker in BOAC, actually. That was in BEA. LORAN, console, radio aids, getting bearings from people, and also astro navigation and taking sun shots, moon shots, star shots.
Yeah.
And the route that was used for the navigation training was London to Bermuda, which sort of concentrated the mind, because if you miss Bermuda, you've got nowhere else to go to. It's 800 miles, the nearest land. So that was really quite interesting for me. I can't honestly say that I enjoyed navigation. I found it, I'm not very neat and tidy with my hands for a start, but it was very interesting. But anyway, then eventually I got back to sort of being a proper co-pilot again, and then I went on to 747s in January 1971. And that was fantastic as far as I was concerned. Yep. It had inertial navigation, and I didn't have to navigate anymore. So that was brilliant. And the 747 is an airplane that I regard as one of the finest airplanes I've ever flown. It's a terrific airplane. And the fact that there's so many of them flying today is really a sort of endorsement of what a wonderful aircraft it is, with all its later versions.
Yeah, they're still building it, right? So it's really still totally active.
I mean, it's a wonderful airplane. It handled beautifully. When you look at this great clunky piece of kit, and you think, God Almighty, you know, and yet it handled really absolutely beautifully. And then I got the chance of a command course in 1976, and I decided I'd go on to the VC-10. Mm-hmm. Which was a very nice airplane as well. And in the spring of 1977, I put in a bid to go on to Concorde. And to my total astonishment, because I was a very junior captain at this stage, I got a chance to go on to Concorde. And that's where I spent the rest of my time in the airline from 1977, the summer of 1977, until I retired in the spring of 1992. So I spent 15 years on Concorde, which was absolutely the ultimate flying experience of all flying experiences.
And that's, of course, what we're going to talk about today.
Yeah.
So, exactly. So you're one of the rare people who got to fly supersonic after leaving the Air Force.
Yes. And all my urge to be a fighter pilot, I became this. I kept a column in my logbook for supersonic flight hours. In total, I have about nearly 5,800 hours, I think, on Concorde, total flying hours on Concorde. And of that 5,800 hours, nearly 4,000 of them were supersonic flying hours.
Mm-hmm. Cool.
Which I always used to make a note of the time we went through Mach 1 accelerating, and then what time we came back through Mach 1 decelerating. And as I say, that worked out at very nearly 4,000 hours of flight time supersonic, which is amazing, really.
Yeah, indeed. So let's talk a bit about the aircraft. I mean, I don't think that there is anyone among my listeners who doesn't have a mental picture of the Concorde and doesn't know the airplane. But it's probably still worthwhile to recap some of its most important features in terms of airframe design, right? So just walk us through the, 3, 4, 5 most important characteristics.
Well, first of all, I think the aerodynamic design was a key part of the whole success of the aeroplane, and it was a successful aeroplane. It did exactly what it was advertised to do. And I suppose the key part of the aerodynamic design was the wing, that beautiful, beautiful wing with all its subtle curves and shapes and twists and everything else. This was all designed not by computer. This was done with models in wind tunnels. And, you know, they would refine the shape of the wing and refine the shape of the wing, test it out, refine it again a bit more. So all those little subtle curves and twists and so on in that wing shape were there absolutely by design. So it was probably, I guess, the last great sort of design project before everything became totally sort of computerized. So that was a key part of it, was the wing design. Another absolutely key element was the engine intake. Without an engine intake that could control the shock wave when you were flying supersonic, you were never going to maintain supersonic flight. And that intake system was a fantastic and clever piece of kit, absolutely crucial to the whole thing.
So I guess it also used ramps and various other things to slow down the air to subsonic speeds before it entered the engine, a bit like the SR-71 where we discussed this also.
Exactly. In the Concorde intake, there were sort of box-shaped intakes, and you had these huge doors that were controlled hydraulically. The muscle power was hydraulic power. The brains was a very sophisticated computer which would calculate for any given moment of supersonic flight the precise angle at which the intake needed to be. And it was designed to control the position of the shock wave in the intake so that it didn't move about. And also, as you've just said, to reduce the speed of the airflow. So when you were flying, for instance, at Mach 2, twice the speed of sound, the air was decelerated from 1,350 miles an hour in front of the intake down to about 500, 550 miles an hour on the other side of the intake. And that deceleration took place through the shockwave, as it were. And then the engine itself, which was about 10 feet behind the intake, would get a nice, smooth, subsonic flow of air throughout the whole supersonic speed range. It was a very, very clever system and worked very, very well indeed.
So you didn't have to deal with a lot of engine stalls as a consequence of bad intake. I mean, the SR-71 had that problem sometimes, right?
Yes, it did. It had what they called engine unstarts, exactly where the shock wave would sort of pop out in front of the intake, that sort of thing. And that got very exciting, I think, on the SR-71. On my 15 years in Concorde, I only had one problem with an intake in 15 years. And that was on a flight from Washington to London. And I was just about to have my meal and putting a nice piece of steak into my mouth, and suddenly the airplane shook and banged about very violently. I mean, it really was quite violent, frightening. And I didn't realize immediately what it was. I thought, gosh, this is turbulence. And then I realized, no, this isn't turbulence at all. This is an engine surge at Mach 2. And you then go through a huge long drill, a checklist, a troubleshooting checklist to try and identify what it was that was causing the problem. In fact, I had a very, very switched on flight engineer, a chap called Bill Brown, who's a very great friend of mine, actually. And he spotted the fact that the number 3 intake ramp had driven itself for some reason. The computer had gone bonkers for that particular intake, and it had driven the intake door, the ramp door, fully shut. So it was basically cutting out. It had forced the shockwave out of the front and basically blocking off air supply to the engine. And the engine didn't like this very much,
Yes.
which was what was causing the thumping and the banging and the shaking. So he had spotted this, and incidentally, the first action of the drill when you have an engine surge at Mach 2 is to close all 4 throttles, which is fine. That stops all the thumping and the banging and the shaking, but it's also what's driving you along at Mach 2. And the deceleration is quite remarkable. All the passengers and the cabin crew come and join you on the flight deck, come and give you a helping hand. Anyway, this flight engineer had spotted the fact that this intake had driven itself fully shut. And he said, look, instead of going through the whole drill, I'm pretty sure it's this intake that's the problem. And I said, Bill, if that's what you think, go for it. And he then hard selected the other computer that controlled that intake, the secondary computer. And we then very, very, very cautiously opened the throttle up fully, and everything was fine. We opened up the symmetrical partner, the number 2 engine, everything was fine. And we opened up the outboards and everything was fine. And that was it. We just resumed Mach 2 and carried on to London. I went around and talked to all the passengers to sort of reassure them. And I mean, this isn't a technical story now, but it's a funny story. When we got to London, I've hopped out of the seat and went back to the front door to say goodbye to everybody, because I thought after this rather frightening experience, the least I could do was to sort of say goodbye to them. Well, Concorde carried an awful lot of alcohol. This lot had drunk the airplane completely dry. They had drunk all the gin, the vodka, the whiskey, the white wine, the red wine, the champagne. They'd drunk the port, the brandy, everything. Not a drop of alcohol was left on the airplane. And they all came staggering off the aircraft saying, thank you very much for a wonderful flight. So, yeah, it was... so that's a great tribute to the efficiency of those intake ramps. They worked very well. I think that's a pretty good record to be able to say that in 15 years of flying the airplane, I only once had a problem with the intakes. So those are the key things: the wing design and the intake design. That's what I would say about it. And the wing design is interesting because at slow speeds below about 250, 260 knots, that wing did not generate lift in the way normal wings generate lift.
Okay.
At those slow speeds, i.e. at those high angles of attack, the way that Concorde wing developed its lift was by creating a huge rolling vortex over the top surface of each wing. And it was the low pressure in that vortex that gave you the lift, not a laminar flow of air over the wing.
Okay.
And in fact, you couldn't actually stall Concorde. The more you increased the angle of attack, the stronger the vortex over the top of the wing became.
In some sense, it was stalled all the time.
Yes, in that sense, yes, it was. But what would finally happen, of course, in an extreme situation, is that the airplane you'd simply lose control of the airplane. The center of lift would move ahead of the center of gravity.
Right.
And then you didn't, you had no more control of the airplane. But that happened at angles of attack of around 25, 26 degrees. We never flew more than about sort of 12 degrees, and the high incidence protection systems would give you very clear warning of if you ever got to sort of dangerous angles of attack.
Okay. Okay. Another characteristic feature, I guess, is the tilting nose for landing. When you came in with these high angles of attack that you could still see over the long nose, it would tilt down.
Yep. I mean, that was purely to give the pilots a view of the runway in front of them for no other reason at all. Yeah. It had no sort of aerodynamic significance of any sort. It was just that if you didn't have the nose tilting down, then you wouldn't be able to see the runway. You'd have a long needle nose sticking up in front of you and no view of the runway.
Yeah.
And we covered that in training. You know, and if it was obviously a concern that if the nose was stuck in the up position, you know, the pilots had to be trained how to be able to land the airplane. So we were taught to land the airplane with the nose stuck in the up position. But the obvious solution to that, if it ever happened, would have been to set it up for an automatic landing.
Oh, it could do that.
Oh, yeah.
Okay.
Oh, it did. It had a wonderful auto land system,
okay.
A wonderful auto throttle system. I mean, we'll come on to that in a minute if you like.
Yep.
But the nose had various positions, well, 3 positions really. First of all, the nose up with the visor, the heat shield, up as well, coming up from the nose cone and up over the windscreen to streamline the shape of the nose for high-speed flight.
Yep.
The next stage was to lower the visor, the heat shield, into the nose cone. So you then had a position where the nose was still up, but the visor, the heat shield, was retracted down into the nose cone.
Yep.
Then you had 5 degrees down with the nose for taxiing, for takeoff, and for flying around the airport area, both on departure and on arrival. And then the final position for the nose was after you'd lowered the undercarriage on your landing checks, you then lowered the nose down to 12.5 degrees. And that put the nose completely out of view of the pilots. You had a really good view of the runway in front of you as you're coming into land.
Yeah, as you said, I mean, it's not something terribly impressive, but it's a necessary ingredient for such a long, sleek-nosed airplane.
Yes, it was. Interestingly, it was very noisy with the nose and visor down. You got a lot of airflow noise on the flight deck, and you had to talk to each other on the intercom.
I see.
It was not easy to sort of talk to each other without the intercom with that nose and visor down.
Yeah.
And then when you brought the nose up and the visor up and streamlined the airplane for high-speed flight, it was like the noise level, it was like just turning a switch off. It was amazing. And it would suddenly become very quiet.
So there is something called Whitcomb's area rule, which applies to supersonic flight. We haven't ever covered supersonic flight in any detail on the podcast. At some point, I'll have to talk to a supersonic aerodynamics guy to cover the basics. But I had one listener specifically asking whether Whitcomb's area rule is applied to the Concorde.
I don't. I'm not really competent to answer that. I don't think it was. I mean, area ruling is sort of wasting the fuselage.
Exactly. Yes.
Yeah. No, it was not. No.
It was not. Okay.
No area ruling.
Okay. So, but then I guess the way the fuselage was designed was or optimized was for supersonic speed. Then I guess. I mean, I think what I understand, I don't know details at all, but what I understand is that this area rule design means that the drag works in subsonic and in supersonic flight because you have different characteristics. And it seems to me that the long, sleek shape of the Concorde was rather optimized for the cruise phase, which is supersonic.
Oh, yes, it was absolutely. I mean, the whole airplane was indeed optimized for supersonic flight. It was only efficient when it was flying along at Mach 2. And the key to operating the airplane was to maintain the highest speed you could throughout the whole of the flight for as long as you could.
Okay. I see.
For instance, if you got into a holding pattern on arrival at Kennedy Airport, flying around at 250 knots in a holding pattern, you couldn't stay there for any length of time. You'd do maybe one turn around the holding pattern, and then you'd have to divert. I mean, you were consuming fuel at a ginormous rate when you were flying in those sort of at those sort of speeds
and altitudes, I guess.
Yeah.
So let's briefly return to the engine. These were afterburning engines, right? That is also, I think, a first or, well, a single case ever that has been done in a civil airliner kind of thing.
Yep. Reheats, afterburners, and that's simply spraying neat fuel into the hot end, the exhaust end of the engine, where that fuel is ignited in the engine exhaust, and it boosts the thrust of the engine by about, I can't remember, about 18% increase in thrust. But it's very, very fuel demanding to have those reheats on. So there were only 2 phases in the flight where you used the reheats. One was for takeoff, and you'd have them on for about a minute and a half or minute and a quarter until you got to the noise abatement time. And then at noise abatement, you'd cancel the reheats and throttle the engines back to a predetermined throttle setting. And the other phase of flight where you used the reheats was for the transonic acceleration from subsonic flight through to supersonic flight.
Oh, yeah.
And you then, when you were ready, when you requested clearance from the air traffic controllers for your climb and acceleration to 50,000 feet, you had to have a completely clear, unblocked airspace all the way from 28,000 feet where you were flying at 95% of the speed of sound all the way up to 50,000 feet. You couldn't stop the acceleration process at any intermediate point. It had to be a seamless process all the way from 0.95 right the way through to Mach 2 at 50,000 feet. No stopping in the middle anywhere. So the air traffic controllers had to guarantee you no conflicting traffic through that whole block of airspace.
So why was that?
Well, basically, you were in an area, a very bad area in terms of drag,
okay.
and the airplane didn't fly very well if you got into that situation. Also, there was a time limit of 15 minutes on the reheats. So it was you simply couldn't sort of stop at 41,000 feet with the reheats still on, because they wanted you to fly at flight level 410 for 5 minutes. That just would not have worked at all.
Yeah. Well, I guess there wasn't a lot of stuff going on in these high altitudes anyway, except the U-2 and the SR-71 and fellow Concordes. Not much was happening there, I guess. So
no, the SR-71 was one example of an airplane that operated in those sort of altitudes, and also, of course, the U-2.
Yeah. But, I mean, it's rather unlikely that one of them is in the airspace you were driving around.
Yep.
I guess
there was never, as far as I'm aware, there was never any conflict.
Yeah.
With the SR-71s or U-2s.
Yeah. So the maximum speed of the Concorde, everybody knows that it goes kind of twice the speed of sound. But what was the actual maximum Mach number, and what was the typical or most efficient cruising speed?
The Mach number was Mach 2, and they decided on Mach 2 because of the heating effect caused by compressibility and by friction. When you're flying at Mach 2, the temperature on the nose, the skin temperature on the nose, would get up to around 120 degrees Celsius. The limiting temperature, the maximum temperature for protection of the structure, was 127 degrees Celsius. And if you were flying in relatively warm air and flying at Mach 2 got you to that limiting temperature of 127 degrees Celsius, the very clever autopilot system would then fly the airplane not to the Mach number, but to the limiting temperature.
Okay.
So Mach 2 was decided on as the maximum speed for the airplane for temperature, skin temperature reasons, to protect the structure for as long as possible. And of course, as a result of that heating of the structure, the airplane got about 9 inches longer when it was all heated up. And you could see that expansion. The only place you could there were expansion joints throughout the whole of the aeroplane and in the wing to sort of cope with this. Really very, very complex stuff, this, from a sort of engineering point of view. And it's, I mean, if you were to say what was the greatest problem associated with supersonic flight, I would answer that it was compressibility and all the consequences, all the problems that flowed on from the compressibility, and the skin temperature rise was one of those problems. I mean, for instance, the cabin floor had to sit on a system of rollers because you couldn't have the cabin floor sort of stretching as the airplane got hot and then contracting again as it cooled down. So the cabin floor sat on a system of rollers so that the airframe could expand and contract without affecting the cabin floor at all.
Wow. That's things, I guess, you didn't, when you designed the airplane, when guys designed the airplane, they probably didn't think of that initially and only noticed later. So, oops, there are challenges we didn't expect.
No, I think they did think of that.
They did? Okay.
Oh, yeah, no, I think they did. I mean, the team of aerodynamicists and engineers, both in Britain and France, I mean, they were very clever people, some of them. I mean, I would call one or two of them geniuses. They really were.
I mean, sure, they thought of it eventually and addressed it, of course. But I think when you start thinking about a Mach 2 airplane, like, you know, like would be cool to have one. What do we have? We need engines. We need, you know, all these cool wing stuff. I don't think that topics like, you know, having a roller-based cabin floor is stuff that you think of initially. That's probably stuff that comes after you do a bunch of analyses and then you notice, oops, that's what I meant.
Yes. No, I agree.
Interesting.
And you see another problem caused by flying supersonic. As soon as you get to Mach 1, you get a shock wave forming on the nose of the airplane. Now, as you go from Mach 1 to Mach 2, that shock wave changes shape. When you're at Mach 1, it's like a sort of just a straight wall in front of you. As you go from the speed of sound to twice the speed of sound, that shock wave gets deflected backwards. And finally, when you're flying at Mach 2, that shock wave is like a cone radiating out from the nose upwards, sideways, and downwards. And that shock wave is traveling with you, this sort of cone-shaped bow wave, like the bow wave on a ship, for instance. That shock wave is traveling with you all the time you're flying supersonic. Now, as that shock wave changes its shape, it has the effect of pushing the center of lift back down the wing, rearwards down the wing, okay?
Yep.
And if you didn't do anything about it, you'd end up with the center of gravity where it was, and the center of lift pushed way, way, way back, and you'd end up with a very, very unbalanced aeroplane with a very strong nose-down pitching tendency.
Yep.
Now, you could cope with that aerodynamically, but that would cause a penalty in terms of drag. So the solution that the designers came up with was that they would pump fuel from the wing tanks at the front back into the tank 11, which is at the tail end of the airplane. And as the center of lift moved back due to the changing shape of the shock wave, as that center of lift moved back, you also moved the center of gravity rearwards as well by pumping fuel back into tank 11.
Yep.
And in fact, by the time you were flying at Mach 2, the difference in the position of the center of gravity by comparison with the position it was in at takeoff, it was about 9 feet further aft than it was at takeoff.
That's significant.
And you have to keep that fuel. It then becomes ballast fuel that has to stay in tank 11 at the back end of the airplane all the time you're flying supersonic. That fuel is not available for driving the engines. It's there as ballast to keep the center of gravity in the right place. And then once you start descending and decelerating to become subsonic again, you then pump that fuel back forwards again, back into the wing tanks, and it then becomes fuel that's available for the engines.
So that means that the deceleration or the acceleration speed, the change of velocity over time would have to be slow enough so that the pumps could keep up to keep the center of gravity in check.
Absolutely.
Mm-hmm.
Absolutely. And that's a very interesting point you raised, because we used to do a lot of charter flights
mm-hmm.
where you just did a sort of 1.5 hour supersonic charter, and we only carried for those charter flights something like 40 or 50 tons of fuel, 40 tons of fuel actually, and that compares with 95 tons of fuel if you were going on a New York flight.
Mm-hmm.
So the airplane was very, very light, and you could get into situations
mm-hmm.
doing those charter flights at those very light weights where the airplane was accelerating so quickly that you could not pump the fuel back fast enough to keep pace with the rate of change of the position of the center of lift.
Yep.
So what we used to do for those charter flights was to start pushing the fuel back into the tail some time before we got the acceleration clearance.
Mm-hmm. And then compensate aerodynamically for the time being.
Yeah. Yes, that was very, very switched on of you to pick that up. On a normal transatlantic flight, it was really never a problem, because the airplane was so heavy and had so much fuel on board that the rate of acceleration was not quick enough to sort of overpower the ability of the pump to pump fuel back.
It sounds like then the system that controlled the pump and was not connected to some kind of measurement of the acceleration, so it would automatically control. It sounded you did that manually and you managed that manually.
Yeah, exactly. It was done by the flight engineer.
Okay. Yeah. Well, there's a point to have them. Right.
He had a very important job to do.
Yeah.
I mean, it was from an operational point of view, from my perspective, and I've flown, as I've told you, the 707, the Boeing 747, and the VC-10.
Yeah.
Concorde, of all those airplanes that I've flown, was the most demanding airplane of all.
Mm-hmm.
Every single crew member, the captain, the co-pilot, the flight engineer, each one of them had to have they had to know exactly what their job was. They had to be very clear that they knew exactly what to do in any sort of an emergency. It was a interesting airplane. It was very, very easy to fly. It had wonderful harmonized flying controls. It was extremely easy to land. It was a delightful airplane from that perspective. The problem with Concorde was it was a demanding airplane to operate. And when if anything ever went wrong, you really did have to know exactly what it was you were going to do about it.
Yeah. I'd like to come back to that aspect a bit later. I have a few more questions about the airplane itself. You mentioned before that 50,000 feet is the altitude you typically cruised in. And I'm sure that was decided or designed into the system, I'm sure, for efficiency. Because if you fly higher, if you can do that, if you fly higher, you're more efficient because the air is thinner. But it also puts you over a lot of the weather and the turbulence. And I can imagine that if you go at Mach 2, then you don't want to run into a lot of turbulence. I'm not sure the airplane would have, been able to sustain the turbulence. Is that correct? I mean, did you rely on the fact that there was little turbulence when you went fast?
Yes, I mean, you've hit on what to me was the most remarkable part of the whole Concorde flight experience. Once you got above 50,000 feet, that's where you got to Mach 2 at 50,000 feet.
Yep.
Then you just cruise climbed. You weren't assigned a specific altitude because there was nothing else up there. And going, for instance, from London to New York, as you burnt off fuel and the airplane got lighter, you would just gently drift uphill, and you'd probably reach a height of about 58 or 59,000 feet on the other side before you had to throttle back to descend and decelerate for your landing at New York. So the airplane would just simply find its own level. It was cruise climbing, it's called, is the technique. So you just left the throttles wide open and left the airplane find its own altitude as it got lighter. Now you were above, as you say, all the weather. You were above the jet streams. You were above the thunderstorms, and the strongest winds you got up at those sort of heights were probably 30 or 40 knots usually. So there's nothing to cause you any turbulence, and it was the most extraordinary feeling. I used to pinch myself in disbelief. I really did, because you had no sensation of movement at all.
Yep.
You felt almost as though you were just hanging suspended in space, and that you were waiting for the Earth to spin around and for New York to arrive below, and then you'd sort of throttle back and re-enter and come in and land.
Re-enter,
sort of thing.
Yeah.
I mean, it really was that sort of feeling. It was quite uncanny.
Yeah.
And the only time you ever were aware of the sort of speed that you were going at was if you happened to be flying over subsonic airplanes on the same track. And they would be doing 550 miles an hour, and you're doing 1,350 miles an hour, and you could see them 20,000 feet below you, and you're going 800 miles an hour faster than they are, and they just look as though they're going backwards. It was quite extraordinary, and that did bring it home to you. And the other thing that really sort of made you realize just what you'd done in terms of speed was there was a flight called the Speedbird 3.
Speedbird was the call sign of British Airways, right? Just to
Yes, there were two flights. There was the Speedbird 1, which left at 10:30 in the morning, and then there was the Speedbird 3, which left at 7 o'clock in the evening. Now, the Speedbird 3 leaving at 7 o'clock in the evening, at certain times of the year, and I'm talking about the autumn and the spring, I would drive up to Heathrow, and I'd see the sunset. I'd take off in the pitch dark, and we would then get up to twice the speed of sound on our way to New York, and 2/3 of the way across the Atlantic, we would then be treated to the spectacle of the sun rising in the west as we overtook it, and you'd then land at Kennedy Airport in the very late afternoon, early evening, and see your second sunset of the day in New York. And that told people far more clearly than simply resetting their watches that they had actually traveled faster than the sun, if you like.
Yeah. It's funny, this notion about not noticing the speed because you're so high, and also this cruise climb. This is really exactly the same story as the SR2, the U2 and SR71 people talked about when I talked to them on the podcast. So it's really interesting that it's so close.
Oh yes, I mean the flight profile for the I used to know a lot of the SR71 pilots who used to be based in England at a place called Mildenhall, which is not far from where I live, and I became very good friends with many of them, and I used to be able to take them for look-see trips on Concorde. British Airways were in those days anyway, were very generous like that.
Yeah.
And they were very impressed at being able to sit there in their shirt sleeves drinking champagne at twice the speed of sound. That was very different from the SR71 experience. But the speeds and the sort of flight profile of the Concorde by comparison with the SR71 were very, very similar. It was just that the SR71, having got to Mach 2, then went on to Mach 3. Concorde stopped at Mach 2.
Yeah. So let's briefly talk about flight control computers. I mean, the Concorde is relatively, or was, built in the 60s, right? So how much, you mentioned the angle of attack, not limiter, but the protection system that let you know when you got too high an angle of attack. You talked about the autoline system. So what other flight control computers or flight management system computers were there on the airplane?
Well, you had inertial navigation, triple inertial navigation with DME updating when you were in range of any DME station. You had a wonderful autopilot system that, as I've already referred to, would fly you through the whole of the profile of the airplane, of the aircraft. It would fly the whole sort of flight profile absolutely perfectly. And as I've already said, if you reach the limiting temperature, the autopilot would then fly not to the Mach number, it would then fly to the limiting temperature. It was a fabulous autopilot, which you hooked up to the inertial navigation system. It then, when you were coming into land, you got fantastic auto throttles, far better auto throttle system than I've ever come across on any other airplane. Those auto throttles in Concorde had accelerometers built into them, and they could pick up wind shear when you were coming into land and compensate for that wind shear without you even knowing about it. Wind shear on a landing in Concorde was just didn't exist because you simply didn't know about it. The auto throttles dealt with it. It had a fantastic auto land system. It was in testing. It was tested up to about 25 knot crosswinds, which is, very, very, that's a challenge. That's a challenging crosswind. That was it. That was in the flight testing. In terms of operational use of the airplane, I think the crosswind limit for an auto land was 15 knots. But in the flight testing program, they took it far, far higher than that. But I mean, in reality, what we're talking about when you need to use an auto land, it's fog conditions, and wind is not the issue there. It's the visibility. And I've landed several times at Heathrow in what are called Category 3 conditions, where the minimum visibility that we were allowed to land in was 200 meters, and the decision height was 15 feet.
15?
15 feet.
So essentially nothing.
So you'd come down the glide slope for the instrument landing system, the autopilot connected up to the instrument landing system, the auto throttles in for your final approach speed, and when you got to 15 feet, you looked out of the windshield, and if you could see 3 centerline lights in front of you, then you could land. If you could not see 3 centerline lights in front of you, then you had to go around and go to your diversion airfield. I've never had to do that. I've always seen those 3 centerline lights. You needed 3 centerline lights minimum in order to keep straight on the runway after you touched down. And so the airplane would then touch down, you disconnect the auto throttles, disconnect the autopilot, lower the nose onto the runway, and then you got to the difficult bit. Having got the airplane down to taxiing speed on the runway, no problems with all of that at all. The problem then was finding your way from the runway to the arrival gate. And we would rely on the ground surface radar at Heathrow to guide us from the runway to the arrival gate.
So they would tell you essentially where to go.
Yeah. Absolutely. But it was absolutely astoundingly good auto land system.
It's interesting. I mean, it's an old airplane. I'm actually a bit surprised.
Well, it was an old airplane, but I tell you what, the thinking that went into it and the technology that went into it for its time was remarkable. I mean, they were absolutely brilliant team of designers and engineers and aerodynamicists. Absolutely brilliant.
So the team was a mixed team between French and British engineers. So it was a joint project between France and Britain, or the UK. These are not necessarily always the two most, well, I shouldn't say non-French, but there have been animosities between the two countries over time, right? So
You're not kidding.
Yes. So I was going to ask whose idea was it, but I'm sure you would answer the British and the French would answer the French. But how did that collaboration work during the design? I mean,
well, I think to go back to the sort of history of it, what actually happened, and we're talking now about the sort of mid-1950s.
Mm-hmm.
So we're talking 60 years ago now. It's amazing, isn't it?
Yeah.
And the British were thinking in terms of a transatlantic supersonic airliner, and the French were thinking of a supersonic transatlantic airliner. And they suddenly realized, both the British and the French, that the sort of designs they were contemplating were very, very similar, i.e. delta-winged, in order to be able to carry the amount of fuel you needed and to give you your supersonic flight capability. And they were talking about sort of a 100-seater aeroplane. So they then realized that this was crazy, that this wasn't going to work at all, to have two competing airliners, one French, one British, both doing exactly the same thing, didn't make a lot of sense. So let's get together and form a partnership and build it as a bi-national project. And that's exactly what happened. And I would argue that probably one of Concorde's great legacies was that the lessons were learned from that collaboration between the British and the French led really to the creation of Airbus.
Right. That's a very good point. And also, I mean, collaboration between politically not always totally aligned countries is not that rare for high-tech, high-expensive, high-risk things. I mean, look at the International Space Station. Sure, it was later, but the Russians and the US collaborate. Even today, when through Ukraine and all of that, there really isn't a lot of sympathy between the two countries, but the space station still works, right? So I guess compared to that case, the French and the British were friends.
Yeah. I mean, what is interesting is that, in fact, there was very little exchange of information between British Airways and Air France when the airplane entered operational service with the two airlines. British Airways made several attempts in the late 1970s, early 1980s to have technical exchange with Air France because they felt it was sort of mutually beneficial for the two airlines to, to be talking to each other about any technical problems they might be experiencing. British Airways never got any answers back from the French. They didn't really want to talk to us, which I'm sad about. And I think that was rather short-sighted. I think it would have been a very good idea if the two airlines had been, throughout the history of the project, exchanging technical information about any problems that they might be having.
That is actually interesting because one of the strengths of the aviation industry is how they deal with, let's say, problems or operational issues that come up over time by reporting them back to the manufacturer, who then disseminates the information to all the operators. I mean, there's a really very good error culture in that sense, and so it's bad to hear that didn't happen.
No, it really didn't, and we did try, and they just didn't really want to. They didn't want to deal with us. The Air France had their own way of doing business, and they didn't want to. They didn't want to talk to us about it.
Yeah. So let's talk a bit about flying the airplane. You already mentioned that it handled very nicely, that from a flying perspective, it wasn't necessarily a grand challenge.
Yep.
So the challenge was more in managing the overall systems, operating it, pumping the fuel, and the coordination between the crew members, right? Is that maybe a fair way of saying it?
Yep.
So what would the roles be? What would the tasks be, the sharing between the tasks of the three crew members, pilot or captain, co-pilot or first officer? I think at that time it was still called co-pilot, I guess.
I think the best way of illustrating that is to put it like this, that if there were no problems going on at all. If there was no weather problems or any other problems, if everything was going absolutely perfectly, then you could just sit there and watch the thing fly across the Atlantic at twice the speed of sound.
Mm-hmm.
But all the time you had to think about what you would do if there was some sort of an emergency. Now, the sort of emergency, if you, for instance, had to shut an engine down halfway across the Atlantic, the first thing is you could not continue to fly at supersonic speed with a dead engine.
Mm-hmm.
So if an engine had to be shut down for some reason or another, because there was a problem with that engine, you were then committed to descending and decelerating. There's absolutely no question about that at all.
Why was that? Wasn't there enough thrust to keep it going at Mach 2, or was this for safety reasons? Or
no. You didn't have enough thrust to keep you going.
Okay.
You couldn't carry a dead engine around with you at supersonic speeds. So you were coming down now, regardless. And you're coming down potentially in amongst the subsonic tracks.
Mm-hmm.
Now, you have to also remember that in those days, all the communication across the Atlantic was high frequency, HF communications, with Shannon, Shanwick we used to call it, and with Gander.
Yep.
And you couldn't just immediately get a clearance to do that descent. You were coming down regardless.
Yep.
So you've now got a situation where this engine has failed. You're descending down. The flight engineer's pumping fuel back forwards from the tank in the tail to make sure that the center of gravity stays in the right place in relation to the center of lift. The guy flying the airplane, either the co-pilot or the captain, depending whose sector it was, is planning the descent because you've got a map of all the subsonic routes. So you're planning to come down between the subsonic tracks rather than into the middle of the subsonic tracks.
Yep.
The chap who's flying the airplane will almost certainly be calling out on 1215 that Concorde is descending down to 38,000 feet and its position is such and such. The co-pilot is on, or the chap not flying the airplane is on the HF trying to negotiate a proper air traffic control clearance from Gander or from Shanwick. And so everybody is extremely busy now. And of course, you've also got to remember, you've got the passengers. So you've got, somebody's got to keep them informed, and the cabin crew, as to what's going on. And you're having to organize a diversion, maybe, because once you'd got subsonic, you were something like 25 to 30% less efficient in terms of range.
Yep.
And you could well be in a situation where you could neither go on to New York nor go back to London. So you were always looking at en route alternate airfields. It was point of no return stuff, this.
Yep.
And you were looking at Shannon. You were constantly, even when the flight was going very smoothly and there were no problems of any sort, you were always checking on the weather for Shannon, for Gander, Moncton, St. John's, Bangor, Maine, Santa Maria and the Azores, because you were always thinking all the time, even when there were no problems going on at all, what would I do if there was a problem now?
Yep.
Would I be able to get back to London? Can I now go on to New York? Am I going to have to sort of think about Gandhi? So all these en route alternates and the weather for those en route alternates were very important, and you were having to check on that all the time.
Yep.
So if you were doing this if you had this problem and you're now coming back down to 38,000 feet mid-Atlantic, the three flight crew, as I hope I've been able to illustrate, were very, very, very busy. There was no room for a passenger there at all.
Yeah.
Each flight crew member had to know exactly what he was doing.
How long would it take roughly to descend from 50K to 38K in such a case? Just roughly.
Oh, 15 minutes, something like that.
Okay. So roughly 1,000 feet per minute.
Yeah.
Right. Okay. So you talked about the auto landing system before and the fact that it landed smoothly. It didn't have any flaps, right?
It didn't have any flaps, no.
So, but that didn't pose a big problem because for the subsonic situation, the wing was big anyway. So you didn't need flaps. Is that? I mean, it's a good way of saying it.
That's a good way of saying it. In point of fact, what we would do, we would adjust the position of the center of gravity to bring the elevons, which were the flight controls.
Yep.
We haven't really mentioned them. That this was a combination of aileron and elevator.
Yeah.
Okay. If you pushed and pulled on the control column, they were purely elevators. If you simply put in roll inputs, they were purely ailerons. If you put in a mixed demand, they became part elevator, part aileron. And they worked extremely well. It was electrically signaled from the flight deck. So it was fly-by-wire.
Yep.
It was the first fly-by-wire airliner. So it was electrical signaling from the flight deck to the hydraulic jacks that were the muscle power that control those elevons. And what we would do for landing, the CFG would be in a position, the center of gravity would be in a position where the elevons were drooping about 2.5 degrees downwards. So the elevons, if you like, almost became a sort of very, very minimal sort of flap as well as being elevons. Yeah.
What was the landing speed, touchdown speed?
A typical touchdown speed would be about 158 knots, 157 knots, something like that. What we used to do, not on an autoland. On an autoland, you had to set it all up, at least sort of 5 or 6 miles out, and have it all nice and stable to make it as easy as possible for the autopilot to do its job properly.
Yep.
But I used to hate doing autolands because the autopilot did the landing better than I could do it, which was very depressing.
Yes.
And I felt I needed the practice of landing far more than the autopilot did. For a normal standard landing, manual landing, we would come in at 190 knots for noise reduction purposes, because the faster you were traveling, the less noise you were making.
Okay.
And also it meant the less fuel you were burning. So you'd come down at 190 knots under auto throttle control. We always used to hand fly with the auto throttles connected. And you'd come down like that to 800 feet. And at 800 feet, you would then plug into the auto throttle system the target speed for crossing the runway, which was typically around 158, 160 knots, something like that. So then from 800 feet down to 500 feet, you had to fly the airplane very, very carefully, adjusting the nose attitude from about 8 and a bit degrees up when you were flying at 190 knots to about 11.5 degrees nose up, flying at 160 knots. So you bleed off about 30 knots of airspeed between 800 feet and 500 feet, adjusting the angle, the nose-up angle, as you bled that speed off so that you stayed on the glide slope. And then for the last 500 feet, you'd be stable at your final threshold speed.
But 158 knots is not terribly much faster than classical airliners. A little bit, but not much.
A little bit, but not much. That's
so
right.
There weren't any limits to the runway length specifically because of the,
No.
Okay.
No. Absolutely not. And in fact, I've landed at Cardiff, which on a charter flight, and that in those days had a 6,000-foot runway, which was the minimum runway length that we were allowed to fly Concorde into. Now, I had not landed a Concorde on a 6,000-foot runway ever before. I had always landed at New York or at London at big long runways. I mean, London, you're talking 11,000 feet runways. At New York, one of the runways we used to use, I think, was 15,000 feet. And here I am coming to land at Cardiff with a 6,000 feet runway in front of me. And I thought, my God, that looks short. And, you know, I was really concentrating on making sure that we came over the runway threshold at the right height. I knew I was going to have the right speed because the auto throttles would keep it at the right speed. And then you'd have main wheel touchdown, down, lower the nose onto the runway, push the control column hard forward to keep the nose wheel firmly in contact with the runway surface. And as soon as you'd got the nose wheel firmly on the runway, you then came in with the reverse thrust and with the very efficient, very effective carbon fiber wheel brakes. And you could stop, well, on that day when we landed at Cardiff, I stopped the airplane in about 4,000 feet.
Wow.
We still had 2,000 feet of runway sitting in front of us.
Cool. It didn't have any spoilers, right? So you couldn't use those.
No, we didn't have spoilers. What we did have was we had in-flight reverse that you could use.
Oh, okay. Wow.
If you needed to come down very quickly for some reason or another, if air traffic control wanted you to expedite your descent, you could come in with in-flight reverse.
Wow. Okay. That's also rare.
Yeah.
Wow. So were there any other special procedures for takeoff or landing or pre-flight checking that differed from, let's say, the 747?
Not really. I mean, the pre-flight briefing was exactly the same for us as it was for any other airplane. You know, you're looking at any airspace restrictions. Weather, of course, was the principal thing. Passenger load, how much fuel are we going to take? What sort of freight are we carrying? I mean, we used to carry a lot of high-value cargo in Concorde. I'm talking now banknotes, jewelry, that sort of stuff, and also things like kidneys and medical organs for transplants and things. We used to carry that quite a lot. So the briefing would be really just the same as for any other airplane. We would always like to get out to the airplane at least about an hour and a quarter before departure time to give us plenty of time to do all the checks. Because there were quite a lot of checks that had to be done of all the vital systems. Well,
you had a lot of time in your 8-hour workday, right? Because your flight was shorter, so you had more time for the pre-flight check without running into your time limits per workday.
Yeah.
Did you have to be aware of the coffin corner, the margin between stall speed and overspeed at the high altitudes? Was that an issue?
No, not at all. Wasn't an issue at all.
Okay. So it was designed in a way that didn't... I mean, the U-2 has that problem, right? It has to be flown very precisely because you'd either overspeed or stall.
Oh, yeah. I mean, that was a problem you had with all the subsonic airplanes. You get too high and you've got a very small margin between a stall and a high-speed buffet. But, of course, we were nowhere near... we didn't have high-speed buffet at all because we was supersonic. So we were a long way from, but there was just the coffin corner did not exist.
Okay. How did the transition from subsonic to supersonic flight feel for you in the cockpit and maybe also for the passengers? Could this be felt? I mean, I'm sure some needle obviously showed it, right? But could it be felt?
I think very frustratingly for many passengers, there was nothing to be felt at all. It was completely, I mean, the only thing that told you that you were now supersonic was the Mach meter. Absolutely nothing happened at all. No bumps, no bangs, no drama, no fuss. Absolutely nothing at all.
Could have used you could have used some sound effects, you know, just use a bang, just so people get their expectations met.
I think passengers often hoped, you know, flying on Concorde for the first time, were hoping there was some great dramatic event would happen as we went supersonic. I'm sorry to say, absolutely nothing, nothing.
Okay. Well, that's good. I mean, dramatic events aren't always positive.
No, they're not. Not in flight.
Yeah, exactly. Yes. So what were the typical routes the Concorde would go? You already mentioned essentially London to New York, right? And Paris, of course, Paris to New York. Was that mainly the story?
That was the important one. But of course, you have to, going back to the history of it all now, when it first entered service in, the first commercial flight of Concorde was on the 21st of January 1976. Air France flew a Concorde from Paris through Dakar in West Africa and then on to Rio de Janeiro. British Airways flew their Concorde to Bahrain.
Mm-hmm.
And for about 6 months, that was all that was happening. Air France was flying to Rio, British Airways flying to Bahrain. Then in the summer of 1976, Washington's Dulles International Airport allowed Concorde to land at Washington.
Mm-hmm.
And this was in the face of great protests because there was a very vociferous and very strong anti-Concorde movement.
Because of noise, I guess, or what was the reason?
Noise was the main thing. And, you know, a lot of these complaints were led, I'm ashamed to say, by the British. There was a very vociferous anti-Concorde movement here in Britain, and they went over to the United States sort of saying, if you let Concorde in here, you will live to regret it. Life will never be the same again, you know, blah, blah, blah.
Yeah.
They've really sort of conjured up an image of doom and disaster if you let Concorde into your airspace. So Washington letting us into their airfield was a major step forward in the face of all this hostility to Concorde. And then Air France and British Airways used to fly from Paris or London to Washington 3 times a week, each airline.
Mm-hmm.
And there was no fuss or problem at all. And people realized that Concorde was just like any other airplane. And then finally, I suppose it must have been about November 1977, New York said, okay, you can come into Kennedy Airport. And we started operating into Kennedy Airport with some very sophisticated noise abatement procedures for when you took off. And immediately Concorde started operating in and out of Kennedy Airport.
Mm-hmm.
The whole opposition to the airplane completely faded away.
So I mean,
and the New Yorkers became the most passionate supporters. People always think that the Americans were very anti-Concorde. They were not.
Mm-hmm.
They were the New Yorkers anyway were absolutely passionate supporters of the airplane.
Mm-hmm.
They loved Concorde. They were very proud of it. They were extremely proud of the fact that there were more Concorde movements into Kennedy Airport than any other airport in the world. And they had a tremendous sort of Concorde supporters group of groupies who used to come out to the airport to watch takeoffs and landings, and they loved the airplane. And the air traffic controllers at Kennedy used to bend over backwards to help us. Mm-hmm. They were fantastic, absolutely fantastic.
So at these low traffic pattern kind of altitudes, was there anything special about the Concorde that the controllers had to consider, or were you just as slow or fast or otherwise agile, flexible as any other airliner at that altitude?
Well, what they had to consider was that we didn't have a huge amount of fuel.
I see.
And
okay.
And that the fuel burn was horrendous flying around at slower speeds at low altitudes. So that was one factor. And the other factor was that we were flying or trying to fly, not all that much faster than the subsonics, but a bit faster, So they'd have to build all that into their thinking. But I'll give you one example of what I mean about the New York air traffic controllers. I was once in a holding pattern at a place called Deer Park, which is just northeast of Kennedy Airport. And we'd done the weather was not very good at New York. And there was a lot of airplanes in the holding pattern. And we did one quick turn. And I said to the co-pilot, we're going to have to divert. Could you tell them that we'd like to divert to Windsor Locks, please, which is about 60 miles northeast of Kennedy Airport. So we called up Kennedy and said, look, we're going to have to divert. And they said, okay, fine. They said, turn left, do this, do that. They gave us about 3 or 4 frequency changes until finally we were on a frequency that no other airplane was on. And then having got us onto this discrete frequency, they said, you're now cleared to turn back. You're cleared for an ILS 22 left approach. They'd taken us out of the holding pattern. They'd Q-jumped us. They'd put us onto a discrete frequency so that none of the other airplanes could hear what was happening. And they then, having got us established on that discrete frequency, they cleared us back to Kennedy Airport to come in and land.
Cool.
And that was the sort of thing they used to do at Kennedy for us.
Yeah.
I cannot sing the praises of the air traffic controllers at Kennedy highly enough. They were absolutely brilliant.
Cool. So the supersonic part of the flight was only over the Atlantic, right? Or oceans?
Yep.
So that means the typical flight profile would be takeoff, and then how would it continue? How high would you typically climb subsonically, and then where would you typically accelerate? Just walk us through the typical profile.
Okay, well, if you're taking off from London to go to New York, we would climb to a height of 28,000 feet and fly subsonic at 0.95 Mach number, and we'd fly over the West Country. We'd fly past Bath and Bristol and Cardiff, out over the Bristol Channel. And once we were out over the Bristol Channel, we'd then call the air traffic controllers and request transonic climb and acceleration. And they would give us that clearance. And we'd then open the throttles up fully, select the reheats, the afterburners back on again. And the airplane would then hang there for about 15 seconds, just below the speed of sound. And then, as we were talking earlier, it would slide through the sound barrier effortlessly, with no drama whatsoever. And all that you'd see was the Mach meter going through Mach 1 and increasing. And you then climb and accelerate with the reheats on until you reached a Mach number of 1.7, which happened at around 43,000 feet. And you then cut the reheats, cancel the reheats, and then you'd coast up rather more gently, and finally you'd reach Mach 2 at 50,000 feet. And that process, going from 0.95 up to Mach 2 at 50,000 feet, would typically take maybe 20, 25 minutes
Okay.
altogether. Then you'd climb all the way across the Atlantic, as I was mentioning earlier.
Yep.
And once you then had to plan your descent to be subsonic at least 55 nautical miles from the coastline. And it would typically take about 110 miles to decelerate from Mach 2 to Mach 1. So as a ballpark typical figure, I mean, obviously there were variations that would come into this, like if there was strong wind subsonic. But typically you would start your descent and deceleration about 165, 170 miles from any coastline, so that you were positively, definitely subsonic, at least 55 miles from the coast,
Yep.
because you did not want to land sonic booms on Manhattan.
Yeah.
That would have been very bad news.
That would make New York not so big Concorde fans.
That would definitely make New York not such a big Concorde fan.
Last question on this fan or not fan thing. Taking off with reheats, I mean, that probably was quite a bit louder than normal airliners. So there was some noise consideration during takeoff, I presume.
Oh, yeah. It was... for that takeoff while the reheats were on, it was noisy.
Yeah.
I loved it. I used to, if I was up at Heathrow and there was a Concorde taking off, I'd just stop whatever I was doing and watch it. Yeah. It was fantastic. Your chest would shake with all the sound waves hitting it. It was just amazing.
Yeah.
Absolutely amazing.
Yeah.
But I have a subjective view.
Yes, well, I guess most aviation enthusiasts have shared that view. People who live next to the airfield maybe do not quite.
Well, funnily enough, because Concorde, well, the British always regarded it as a British airplane.
Right.
And I suspect the French always regarded it as a French airplane. The British, because they regarded it as a British airplane, were incredibly proud of it.
Yeah.
And somehow, people who used to object about noise from a 747 or whatever, they didn't object about Concorde.
Yeah.
It's very, very peculiar.
Mm-hmm.
I mean, I took Concorde to Luton Airport on some charters back in the mid-1980s. And I went to see the airport director at Luton before doing these flights. And he was very concerned about the noise and the noise complaints that he was going to get. And I said, well, I'll do the best I can. But, you know, it is a noisy airplane at takeoff, and we just have to accept that. Anyway, I did all these charters. And a couple of days afterwards, I rang this airport director up and I said, well, David, I said, did you have lots and lots of complaints? He said, no. He said, you can come again anytime you like. All we've had is phone calls saying, when's Concorde coming to Luton again?
Yeah. Right.
So, it was funny. Concorde became very special in the British psyche.
Yeah.
And remains that way to this day.
Yeah.
It's extraordinary.
Yeah. Absolutely. So let's talk a little bit about emergencies. You mentioned some things before. For example, if one of the engines cut out during supersonic flight, you had to get down because you couldn't sustain the supersonic flight. Were there other, let's say, special emergency procedures for supersonic flight, or maybe during takeoff, if a reheat would cut off? I mean, I guess you couldn't probably. Could you still take off? So were there special emergency procedures for the Concorde?
You could accept the failure of a reheat during the takeoff run, but you could also do a transonic acceleration with only 3 reheats operational.
Mm-hmm.
So you had a bit of latitude there.
Mm-hmm.
No, what was the question again?
Well, just generally special emergency procedures. I could imagine flying at almost 60,000 feet towards the end of the cruise climb. If you get a depressurization event there, you had to do something quickly. Or, I mean, were there any special procedures?
Well, yeah, I mean, depressurization, that was something, obviously, that was of great concern. And you would have to do an emergency descent if you ever had a depressurization. That, of course, is why the windows in Concorde were very small. They were very cleverly designed to make them look as though they were fairly large, but in fact the windows were very, very small indeed. And you could, if a window had blown out, and I don't know of any case where this had happened, so I don't think either in Air France or in British Airways this actually ever happened. But if a window had blown out, you would not have an uncontained pressurization failure. The pressurization system would still be able to cope with the fact that the window had gone.
One window.
one window.
Yeah.
The authorities, when they were certificating Concorde, were very concerned about, if the airplane had been up at 60,000 feet, was it going to get down quickly enough for people to survive?
Yep.
Well, you could get from 60,000 feet down to a viable altitude like sort of 40,000 feet in probably about 5 or 6 minutes, something like that.
Mm-hmm. Oh, that's quick. Mm-hmm.
So you could get done pretty quickly.
Mm-hmm.
But the reality it was that we never had problems of that nature at all.
Mm-hmm.
I think that if I was to come up with a weak point in the airplane, it was the hydraulic system. There were 3 hydraulic systems. We called them green, blue, and yellow. And they were supposed to be completely independent of each other,
mm-hmm.
although quite mysteriously, sometimes hydraulic fluid would transfer itself from one system to another. But if you had a hydraulic leak, that was a problem that really concentrated your mind, because the hydraulics were so vital to the aeroplane, and they were prone to having hydraulic leaks. I've had I don't know how many occasions in my 15 years on the airplane, maybe 6 occasions in that time, had to go back to subsonic flight and divert somewhere because of a hydraulic problem.
Interesting. But generally, it sounds like you considered the aircraft safe or good aircraft and a solid thing to work with.
Oh, I mean, it was built like a proverbial brick lavatory. I mean, it had a very thick aluminium alloy skin. I mean, structurally, it was a really tough airplane.
Yeah.
It may have been beautiful to look at, but it was very, very strong.
Mm-hmm.
All the systems worked extremely well. The electrical system, the pressurization system, the auto-flight systems, all these things worked incredibly well. The weakest system was the hydraulic system.
Yeah. Okay.
And that was the one that always, if you had a hydraulic leak, you really were concentrating on monitoring the rate of that leak and what you were going to do about it, because, obviously without hydraulics, you hadn't got a flying machine.
Yeah, yeah. So in terms of training, were there meaningful simulators back then?
The training took 6 months. The first 6 weeks of it was ground school, where you had an exam every week and you had to get a minimum of 94%, I think, on all the papers every week. Otherwise, you failed.
Mm-hmm.
And you then had an exam set by the Civil Aviation Authority at the end of the ground school, where it was something like 220 questions. And again, you had to get well over 90% to pass in all the different sections. You then moved to the flight simulator, and that was located at Bristol, at Filton, where the airplane was made. And you did about 85 hours in the flight simulator.
Mm-hmm.
The flight simulator itself was very good. The visual system in those days, back in 1977 when I went onto the airplane, was appalling. It was one of those terrain maps with a camera that tracked over the terrain, and it was absolutely hopeless as a visual. In fact, it made like, I never used to look out because I didn't want to see the visual picture because it was so unrealistic.
So it was more like a procedures trainer then?
I mean, it handled just like the airplane. It was very close, very faithful to the feel of the airplane.
Okay.
It was much more than a procedures trainer. It did faithfully replicate the handling qualities of Concorde. What it didn't replicate was the visual view outside the windshield.
Okay.
And then in the mid-1980s, at huge expense, they tore that clunky visual system out of the simulator and replaced it with a computer-generated visual, and that was a huge improvement.
Yeah, I can imagine. Yeah, and it had a hexapod, so it did move, the simulator, or was it fixed base?
Oh no! It was full axis simulator. Okay. Yeah. You're moving around all over the place. And if any of your listeners ever want to fly a Concorde simulator, that Concorde simulator is now located at a wonderful museum just south of London, near Weybridge, at a museum called Brooklands. And you can buy yourself time on a Concorde simulator. I went and flew it the other day. And it was brilliant. And what happened was, when the Concorde project came to an end, they moved the simulator. They had to cut all the cables and everything else.
Yeah.
They moved the whole simulator over to Brooklands. And then a team of dedicated enthusiasts and electricians, obviously, reconnected the simulator. And they've now put into it a visual system, a computer-generated visual system that is far, far better than the one that I ever had when I was flying the airplane.
Probably connected to X-Plane.
It's absolutely brilliant.
Yeah.
It really is. It was just terrific.
Yeah.
So if anybody wants to learn a bit about Concorde and what it was like to fly it, get over to Brooklands. They've got a website, obviously.
We'll link to it.
And go and fly a Concorde simulator. They look after you very well.
Cool.
And that's run, incidentally, by a group of retired Concorde pilots.
Okay.
I would love to be one of them, but I live so far away from Brooklands, it doesn't make sense.
Right.
It takes me about 2 hours to drive to Brooklands.
Mm-hmm. Well, that's almost as long as it took you to fly to Washington.
Yeah, absolutely.
So were there any challenges for you and for the flight attendants to manage, let's say, a flight crew with, a set of passengers with only first class and perhaps important people? Was that something that influenced your work in any way?
I don't think so. I mean, I've flown, obviously, by definition, all sorts of important people. And very interesting people, ranging from Her Majesty the Queen and the Duke of Edinburgh on a royal flight to the United States in 1991. That was fantastic. And from there, I mean, I could come up with a sort of who's who. I mean, I've flown Henry Kissinger, I've flown Douglas Hurd, I've flown Muhammad Ali, Lauren Bacall, Paul Newman, Paul McCartney, Elvis Costello, Yitzhak Perlman, Vladimir Ashkenazi, Menowin, Sir George Schulte, Horowitz, Isaac Stern. I can come up with Julia Roberts. I can come up with endless names.
And did you have any contact to these people, or were they just somewhere behind you in the cabin? I mean, was there any...
No. We used to have an open flight deck door.
Oh!
Flying was fun when I did it.
Mm-hmm.
None of this business of being locked up on the flight deck. We had an open flight deck door, and we used to invite passengers to come up and visit us.
Yes.
So I've talked to all these people. Amazing. Absolutely amazing.
Yeah.
I've spent time talking to people that in normal life you'd never meet.
Yep.
And by and large, the great majority of these very famous people that I flew were very modest and ordinary and down to earth.
Yeah. Yeah, I can imagine, especially in that kind of environment. I mean, clearly in that environment, kind of you're in control and they are not, right? So, I mean, there's...
That is very true.
That helps. Yeah. So is there any truth to the story that they tried titanium cutlery but then switched back to steel because people thought it tasted better? Is that true or just a rumor?
I don't know. I've never heard that.
Okay, then let's forget about that one. It was a specific...
Forget about that one. We always had stainless steel cutlery.
Okay. So let's finish up our conversation by zooming out again and talking about the retirement and a bit of outlook. Retirement of the Concorde, not of you. So I think the question that people are interested in is why the Concorde was discontinued. One listener kind of had this nice statement. He said, "I thought it was the beginning of a new travel age, or age of travel." And to me, people ask themselves why after Apollo we didn't continue to, build actual colonies on the moon and fly to Mars. And some people say Apollo was a kind of historic accident. It was motivated by not necessarily sustainable criteria, but by the Cold War. And so sometimes I think the Concorde is somewhat similar, right? It was built as a prestige project, I guess. It did have its use. It made money at the end, but it maybe still used too much fuel. So what's your thought on that?
Well, I think what you've said is a fair comment. It was a prestige project. There's no doubt about that. It made a lot of money for British Airways. People often get very confused about this, but you have to remember that when British Airways took on these Concordes in 1976, it was a nationalized airline at that time, and the British government simply said, "You will take these airplanes."
Yeah.
And British Airways didn't want the airplanes.
Mm-hmm.
They didn't want anything to do with it. And in the end, the British government said, whether or not you want to have the airplanes is irrelevant. You are going to have the airplanes. You're a nationalized industry. We, the government, are telling you you're taking on these Concordes. And British Airways took them on. They paid, I think, £1 per airplane as a sort of transactional fee. So they never had to write off the capital cost of each of those airplanes. Mm-hmm. As far as I'm concerned, we, the British taxpayers, always owned those airplanes. Mm-hmm. And British Airways were merely the trustees or custodians of the airplanes.
Yeah.
And those airplanes, when you consider that they never had to write off the capital cost of 7 Concordes at £55 million each, they were making money hand over fist with those airplanes. And there was one year in the mid-1980s when the 7 Concordes made 20% of the airline's profits in that year.
Mm-hmm.
And the way we used to do the Concorde fares was every now and then they'd have a survey amongst the regular passengers, people like Rupert Murdoch, David Frost, people like that. What do you think you paid for your Concorde flight today? These people haven't got a clue what they paid for the Concorde flight today.
Mm-hmm.
They just tell their secretary, book me on tomorrow's Concorde.
Yeah.
I need to get to New York in a hurry. And they put down figures. Oh, I don't know what I paid. £4,000, £3,000. And British Airways would average these guesses out, and that became the Concorde fare. So they were charging people what they thought they were paying. Mm-hmm. And making vast sums of money with it.
But I mean, this only worked because there was no capital cost in buying the airplane, but there was still operational cost. I mean, again, coming back to the fuel consumption, how much worse was it than a subsonic?
By comparison with your 777s, horrendously worse.
Yeah.
I mean, we on a typical transatlantic flight to New York, we would use 80 tons of fuel. Mm-hmm. I don't know what a 777 uses going across. Yeah,
I don't know either. And of course, you would have to calculate per passenger for this to make any sense. And I don't know these numbers either.
No. We won't go down that road. But it wasn't fuel efficient.
Yeah.
It was very fuel efficient when it was flying at Mach 2. Incredibly fuel efficient once it was up there. But to get it up to twice the speed of sound, I mean, basically, you use half the fuel for the transatlantic crossing, for the takeoff, the transonic acceleration to get it up to Mach 2.
Yeah.
And then it was sort of like going downhill all the way after that.
So what then was the reason for its discontinuation? Was it essentially the accident in France?
Definitely. I mean, in my opinion, absolutely, definitely.
Okay.
And I've got very strong feelings about this, and I get very upset about it.
Okay.
The French, in their accident report, blamed that accident on two things. They blamed it on a piece of metal left on the runway by a DC-10 Continental Airlines and design weaknesses in Concorde. It was absolutely nothing to do with design weaknesses in Concorde. That was rubbish, that statement. The piece of metal left on the runway was an element in the whole chain of events that took place that day. But basically, that accident was, I'm sorry to say this, and I've done lectures on it in France at a French aerospace conference in Lyon, and also to sort of European airline pilots in Nice. And I make no bones about this. That accident was caused by a whole series, not only of operational errors on the part of Air France, but also there was one very significant maintenance error. The maintenance error was that they had stripped down the left-hand undercarriage leg 2 or 3 days before the crash. And in the process of rebuilding that undercarriage leg, they had failed to put back into that undercarriage a component called a spacer, whose function is to space the left-hand and right-hand pair of wheels on the undercarriage truck, but also that spacer kept the wheels locked in proper fore and aft tracking alignment. With the spacer missing, those wheels had the ability to wobble around like wheels on a supermarket trolley. So that was one thing.
And how did that contribute to the accident?
Well, I'll come on to that in a minute.
Okay.
The operational failures, well, there were several, I'm afraid. First of all, the crew decided, the captain, I guess I have to say, decided that he wanted to take as much fuel as possible, and he authorized the refuelers to override the normal refueling systems, which cut off at about 82% of tank capacity, so that you've always got airspace left in the tank. He authorized that protection to be overridden and for the fuel tanks to be filled up completely. So there's no airspace in them. He authorized 2 tons of taxi fuel, and that taxi fuel was in tank 11 in the back. So we've got a situation where this airplane has got completely full fuel tanks in the wings, and in the tail tank, it's got, on top of any other fuel, it's got 2 tons of taxi fuel. He then was told about half an hour or so before departure that they were not going to be able to load 19 bags onto the airplane. And he said, "Oh, isn't there space for them?" And the dispatcher said, "Yes, there's space for them, but, for weight reasons, you're not going to be able to take them. You're going to be overweight." And the captain said, no, just stick them on the airplane then. And they were put into a cargo hold at the back of the airplane, very close to tank 11 that I've been talking about. They then get their taxi clearance, and instead of having any delays for takeoff, in a few minutes, it's a very short taxi from the Air France terminal to this runway that they were using, 26 right. There was no other traffic around, and they're cleared for takeoff almost immediately. They had only burnt 800 kilos of that 2,000 kilos of taxi fuel. So just let's think about this now. We've got 1,200 kilos of taxi fuel that should have been burnt before takeoff, that has not been burnt, and that's fuel at the back of the airplane. You've got 19 bags that were stuck on at the last moment that were never weighed. And remember, these passengers, mostly from a small town in Germany, as I remember it, if not all of them from the small town in Germany, were going on a trip of a lifetime to join the Deutschland, the cruise ship.
Mm-hmm.
So I doubt that their baggage was light.
Yeah.
And I think you've got to assume that those 19 bags would have weighed something like 500, 600 kilos, something like that.
Mm-hmm.
So you're talking about a total of roughly 1,700 kilos
Mm-hmm.
of weight that was at the back end of that airplane that shouldn't have been there. The airplane was actually over the maximum structural takeoff weight at
Mm-hmm.
the start of its takeoff. It was beyond the aft limits of center of gravity for takeoff because of all this weight that was at the back end of the airplane that should not have been there.
Yeah.
And they accepted a clearance with an 8-knot tailwind.
Okay.
They were given a clearance for takeoff on 26 right, wind 090, 8 knots.
Mm-hmm. Mm-hmm.
They had an 8-knot tailwind. That, if you factor in the tailwind into all the calculations, that put the airplane about 6 to 6.5 tons over the weight it should have been at.
Mm-hmm.
Quite a gross exceedance
Yeah.
of all the sort of authorized procedures. Then, this gets very detailed now.
Yeah.
The first few hundred meters of the runway were actually closed because it was not fully resurfaced, and the captain asked for permission for the full runway length.
Mm-hmm.
And the control tower authorized him to use the full runway length. This meant that when he got to the transition area between the not complete runway surface to the complete runway surface, where there was a ledge, a lip, call it what you
A bump.
like, this transition from the incomplete runway to the complete runway, I think what happened then is that when they reached that point during the takeoff run, that triggered the wheels to skew around on that left-hand undercarriage leg. And there are certainly reports from very credible eyewitnesses, including the captain of an Air France Airbus that was next in line for takeoff, that say that there was smoke and flames coming from that left-hand undercarriage at a very early stage of the takeoff run.
Mm-hmm.
Those verbal reports have been suppressed by the French authorities. The airplane eventually ran over this piece of metal, and a 4.5 kilo lump of rubber was sliced off that front right-hand tire on the left-hand undercarriage leg.
Yeah.
And the airplane at this stage was doing 173 knots, so 200 miles an hour, 40 kilometers an hour, something like that. What the rotational velocity on the wheel was, I have no idea, but it doesn't require a huge effort of imagination to appreciate that this piece of rubber almost parted company with the speed of a missile, and it went slamming into the underside of the wing by tank number 5 with the force of a missile strike.
Yep.
And it set up a shockwave in the fuel tank, which was completely full, had no airspace in it. And there was nowhere for the energy in that shockwave to go. It had to go somewhere.
Yeah.
And it was actually not a penetration of rubber into the fuel tank. It was an explosion of fuel out of the fuel tank.
Because of the pressure wave.
Because of this shock wave, the pressure wave.
Yeah.
Exactly. It was a burst of fuel out of the tank, and they know that, and it's acknowledged in the accident report, because the metal in that fuel tank was all petaled outwards not inwards. That fuel then came pouring out of that tank, and it came in contact with the electric wiring for the brake fans on the left-hand undercarriage leg, which had been damaged by the fact that these wheels had been tracking sideways down the runway from a very early stage of the takeoff, and there was electric arcing going on in the wiring there, and that was the ignition source for the fire, and the rest, as they say, is history. The aeroplane never got above 200 feet altitude. It never got above 198 knots speed. It never got remotely close to the safety speed. The safety speed for that takeoff was 220 knots. And then finally, of course, it lost control and crashed into the hotel at Gonesse. An absolute tragedy. And it's a tragedy that came about as a result of a whole lot of errors on the part of Air France, not anything to do with design weaknesses in the airplane. It was an accident that should never, ever have happened. It really is. I feel really strongly about it, and I've talked about it whenever I get an opportunity to talk about it. I do a full lecture on it that takes about an hour. I've condensed it greatly. I mean, there are all sorts of other things I could go on about. I've just come up with the bullet points here.
I mean, in some sense, it is not surprising that the accident is the consequence of a whole sequence of events or bad decisions or stuff that shouldn't have happened. I guess that's mostly true. That's true for most accidents, which is why they are so rare, right?
That's exactly right. I mean, it was a classic aircraft accident.
Yeah, exactly.
It was a whole chain of events. And it was the cumulative effect of all these links in the error chain that led to the final catastrophe. Yeah, absolutely.
And so do you think the accident was used as an, let's say, excuse to shut down Concorde operations? Would they? How long do you think they would have continued? I mean, sure, the airplane made money, but I could imagine that maintenance became progressively more expensive. I don't know. What about spares? So how long do you think? I mean, it's hard to talk about alternative history, but what's your thought about what would have happened if there had not been the accident?
I'll answer it in a slightly different way. I think because of that accident, Air France, from that moment on, never wanted to operate the airplane again.
Yeah.
If they could have grounded it then and there, back in July 2000, they would have been very much happier. But unfortunately for them, it was an Anglo-French cooperative project, and the British didn't want to stop it there and then. They wanted to get it back in the air again. So various modifications were done. They put Kevlar linings in the fuel tanks to protect the fuel tanks from penetration, but as I've already explained to you, it wasn't a penetration of rubber of tires into the tanks. It was a burst of fuel out of the tanks. They beefed up the electrical wiring for the brake fans. They fitted new tires, near zero growth tires they were called, made by Michelin, which were very good tires incidentally. And 17 months later, Concorde was re-inaugurated back into service to New York just after the dreadful events of 9/11. And I know that Mayor Giuliani came out to the British Airways Concorde, certainly, and welcomed all the passengers. He got onto the public address system and said how wonderful it was to see Concorde back in the skies of New York after the dreadful events of 9/11, and how this was a symbol of hope for the future. I mean, he did a very emotional sort of speech on the Concorde's public address system to all the passengers before they got off. And at that point, I thought, and we're talking November 2001 now, I thought the airplane had another 15 years of life left in it. So it could have been flying to 2016. What then happened was that in the run-up to the Second Iraq War, and you may remember this, the French and the Americans disagreed strongly about whether or not we should be going into that war. I happen to think, personally, for what it's worth, that the French were right and the Americans were wrong. We should never have gone into Iraq War II. But the Americans got extremely upset with the French, and the Americans, in their sort of wonderful way of dealing with things, boycotted all things French. They boycotted French fries.
Freedom fries, well, they were called, right?
Yeah. And they boycotted French cheese, French wine, French holidays, and, of course, Air France. Well, guess who most of the passengers were on Air France Concorde? They were mostly Americans.
Yeah.
And suddenly Air France found itself flying across the Atlantic with pathetic passenger loads, and they were hemorrhaging.
Right.
And they went along to Airbus and said, hey, guys, we can't go on like this. We're going to have to do something, because we simply can't go on operating Concorde with passenger loads of sort of 10, 15 people going across the Atlantic. And Airbus, who had simply inherited the product support responsibilities, type certification responsibilities for Concorde from the predecessor manufacturers, said, hey, if you don't want to go on flying it, I'll tell you what we'll do, we'll hike up the product support costs for the airplane to a level that British Airways can't afford. And that's exactly what happened.
Okay, wow.
And British Airways, I'm sorry to say, caved in, capitulated to this sort of ultimatum from Airbus, instead of challenging them in court, which I think they should have done. And that was the end of Concorde, basically, in a nutshell. It could have gone on. It, 7 British Airways Concordes. I've already mentioned the people who flew Concorde had no idea what the fare was.
Yeah.
That was completely irrelevant to them. And they're more than enough, even in this sort of rather dismal world that we live in now, got more than enough money to not bother about what the Concorde fare is. They just want to get across the Atlantic in 3 hours. Thank you very much.
Yeah, I think also that there would be a small, but there would be a market, even if it's a small one, for that kind of airplane.
Yeah,
people
absolutely.
who would pay for that. So do you think if there was some eccentric billionaire, who would like to bring one back as their private plane or just as a gimmick, do you think it would be possible to bring a Concorde back? I mean, can Airbus be bribed at whatever price to deliver the spares and, I don't know, maybe add some avionics refresh or something? Is that feasible? It's probably not going to happen, but do you think it's possibly...
I personally don't think it's feasible. I mean, for instance, with the British Airways Concordes, British Airways insisted that all the hydraulic fluid and engine oil was drained out, so all those pipe runs have dried out, the seals have dried out. You'd have to plumb in a whole new sort of coronary artery system into the airplane to make it viable.
Yeah.
I don't see it happening at all.
So they are now...
I have to say another thing which I didn't mention, and to be fair about, to try and be sort of reasonably objective about this, there is no doubt that the engineering problems that Concorde was presenting were getting quite tricky, because it was a proper aeroplane that needed proper engineering done to it. I mean, nowadays with all these modern airliners, you simply take a black box out.
Right.
If something's not working, and put another black box in.
Yeah.
It's a totally different sort of way of going about it. And as time went on, it was going to become more and more of a problem to have the engineers with the skills and the expertise to maintain Concorde.
Yeah, well, and that in the end is a cost issue, right? I mean, you can always...
And it becomes, yes, absolutely, it becomes a cost issue.
Yeah.
You can always train them.
Yeah, exactly, yeah.
But for just 7 airplanes, hell, do we want to go down that road?
So these days the airplanes, I guess, are all in museums. None of them has been scrapped, I hope. I know that one of them is in Sinsheim in Germany. I fly over the Concorde all the time with my glider. Usually low, because Sinsheim is usually an area where there's bad thermals. So they're spread all over Europe, all over the world, or where are they?
I don't know where the Air France ones are. Well, I know they've got one at Charles de Gaulle. Oh no, at Le Bourget, I think.
Mm-hmm.
And there's one at Toulouse. And you've talked about one in Germany. Where the others are, I don't know.
Okay.
In the British Airways ones, there's one at the... Oh, another Air France one is, of course, at the Smithsonian Museum in Washington.
Ah, yeah.
I should have remembered that.
Well, you did.
I did. Just.
Yeah.
The British Airways ones, there's one in the Museum of Flight at Seattle.
Mm-hmm.
There's one at the museum, the Intrepid Museum at on the Hudson River in New York. There's one in Barbados, which is the best Concorde of the lot, that lives in a hurricane-proof hangar.
Mm-hmm.
If anybody's flying to Barbados, that museum housing that Concorde is right alongside the airport at Barbados, and they look after it beautifully. It's absolutely wonderful. It's in, as I say, a hurricane-proof hangar. It's cleaned and polished and looks absolutely beautiful, and they do a wonderful sort of Sonne Lumiere entertainment on the side of the airplane. It's just very well done, well worth seeing. Then there's one at Brooklands that I've already mentioned. There's one sitting at Heathrow, unloved. There's one at Filton, which is the British birthplace of Concorde, and that too is just closed. Nobody does anything with it. There's one at Manchester, which is very well presented, and there's one in Edinburgh.
Yeah, okay. I've been in Edinburgh. Should have gone there. Cool. Very nice. So, did you fly anything else after Concorde, or did you take the opportunity to retire?
I thought about flying for sort of Singapore Airlines, but when they realized that I hadn't flown a 747 for quite a long time, they weren't really interested in me. And I'm not sure I'd have wanted to go back to flying subsonic again after 15 years of supersonic. So I now fly a little aeroplane called an Oster-Eglet that, if I'm lucky, flies at about 80 miles an hour. So I've gone from the sublime to the totally ridiculous.
Well, you've had the high speeds, so you can now fly slow, I guess.
Yep, absolutely.
So is there I'm out of questions. Is there anything else you want to mention for our listeners? Anything else you want to add as a kind of closing remarks?
No, I just think I've been very privileged and very fortunate. I've flown, I think without doubt, the most iconic and wonderful airliner that's ever been made. And I've been very privileged to do that for 15 years.
Yeah.
It was a remarkable achievement. You know, the technology that went into it has to be ranked with, you know, the whole Concorde project has to be ranked as a sort of European equivalent of the Apollo lunar landing program. It really was, you know, the challenges involved were of that sort of same order of magnitude.
They were different, of course, but certainly not necessarily simple.
Absolutely different challenges, but very complex challenges.
Yeah.
And, you know, they came up with fantastic solutions to all these problems. And to me, I think it was a British architect, Sir Hugh Casson, who once said of Concorde that it was a piece of 20th century sculpture. And I think that says it all. It was a fusion of art and technology into one sublime, beautiful creation. It was a wonderful airplane, and I still think passionately about it. I love that airplane more than words can ever say.
Yeah, I did notice that during our conversation here.
Good, well, I'm glad I got it across.
Yes, absolutely. So, well, John, thank you very much. I think this was a wonderful conversation. I mean, this was exactly what I hoped for. Thank you very, very much for taking the 2 hours to talk with me and my listeners here. I really appreciate it.
Okay, well, we must keep in touch, and if you're ever coming to England, you must come and visit us.
Okay, I am in England regularly every year, so that may actually happen.
Well, keep in touch.
Thank you very much.
Well, it's
Bye.
very, very nice to talk to you, Markus. Bye-bye.
Thank you. Ciao. So, that's it. I want to thank John for taking...
Okay, I hope you enjoyed the interview. Quite bad at small talk, so therefore I tend to play that interview. It's very interesting. It's like the 5th time I listen to it. It's every time it's interesting to listen to his stories. Anyhow, we're back subsonic now, and I just realized I forgot to put in some de-ice. There we go. We are now subsonic over the coast of England. Actually, we're just flying across above an airfield called Swansea, which should be below us. And I don't know that by head. I'm cheating. I looked at the VATSIM. We will shortly start to descend into London Heathrow. Currently flight level 350. We will start to descend into Heathrow for the Occam 2 Foxtrot arrival. I think it's a westerly configuration there. Yeah, so I will go for 27 left for landing. Switching this to the Occam frequency now, setting in the inbound course of 093 degrees. Which is the radial 273 into Occam. I'll reset my altitude to flight level 140. Yes, it's an Occam 2 Foxtrot arrival. Now the... No ATC online, I'm afraid, into London Heathrow for some reason. I mean, it usually is, at least, you know, London Control or Heathrow Direct, but apparently not today, of course. Current indicated airspeed is 300. I have set in the speed window here 340 knots and activated indicated airspeed acquired, so the auto throttle will give or take a bit thrust to try to maintain 340 knots, but current speed is 345 indicated airspeed and a ground speed of 630 knots. But we are well below subsonic at least, so the Englishman can't complain of any sonic boom carpets, so that's good. we should be at flight level 140 at Bedek, and Bedek is waypoint 9, so I will have a look at the INS here and try to think ahead a bit. So we will be at flight level 140 once we get to Bedek. So I will increase my descent just a bit, so we are on the right side, so to say. I think 3,000 feet per minute would be a good start. Is it very difficult to bleed off airspeed? It can be a bit difficult when you have the nose and visor up and you are descending like I'm doing now at 3,000 feet. I mean, it's no chance for me now to reduce speed to 250 knots by just pulling to idle. I need to reduce my descent rate as well to reduce the speed. If I have any restrictions though, I have the ability, as John Hutchinson said before, is that I have the same, I mean, I can do the in-flight reverse on the inboard engines, which is very neat if you got any restrictions by the ATC or maybe need to descend a bit quicker. I mean, if the ATC tells me to expedite my descent, you can bet I'm expediting my descent when I doing the idle reverse and descending of 350 knots indicated airspeed. Then I'll probably do like 6,000 or 7,000 feet per minute descent rate. Is that the same SIVA gauge that was in the old FSR? I'm not sure, but I know this one is used in a 747-200 Classic at least. But it well could be the same INS gauges. It's SIVA at least, or Charlie India Victor Alpha. That's the name of it at least. 2 minutes to go to our intermediate point, so to say. We've got 2 minutes to go and we're descending with 3,000 feet per minute, and that equals 6,000 feet. So that means once we get to waypoint 8 we'll be at around flight level 180, which is pretty good because then it's only 4,000 feet to descend to Bedek then. Yes, you can reverse the inboard engines. If you go here to the engine controls panels, you have something called flight reverse arm. If I open that or left click there, I can go into reverse. I won't do that now, but it can do that. It gives you a pretty good descent rate. We've got a pretty decent tailwind, 240 knots, 240 degrees 67. So from here the wind comes. So I'd say like 30 degrees of a tailwind, something like that. Pretty good. I will turn off the auto throttle for a little while and go to full idle, just to keep our speed a bit lower. Shame that we didn't have an ATC online, because I hate to type on Unicom. So now you can see we have 2.5 minutes almost to Bedek. So we can reduce actually to 2,000 feet per minute of descent rate. You just passed the north of Bristol. All right, okay. I don't have the slightest clue. I can only relate to the waypoint 0 along the way. Trying to write something in the ATC or the Unicom. Set the fasten seatbelt sign. 1 minute to go, we're already at flight level 155, so it will be no problem to get to flight level 140 at the moment.
Altitude alert, 1000 to go.
Can actually reduce the descent rate a bit. And when we are starting to flying to the next waypoint, I will switch to radio navigation here, so that we can see when we are about to catch the radial 273 to fly into Occam. Radial 273 corresponds with an inbound course of 093 degrees. And as you can see, I've set in the Occam viewer here. And I might as well also set in the ILS frequency already now for ILS 27 left on the nav radio 2, just as a reminder, which is 109.5 and an approach course, of 272. On the charts it says 271 actually, but my simulator is a bit older, so that's an inbound course of 272. I always tend to double check via VATSIM commander what the inbound course says. It can differ from time to time. We'll continue now down to flight level 80. Also start to reduce my speed to 250 knots. So what I usually do now is to set the INS to manual here, so I can capture the localizer nicely here. Not the localizer, but the radio. So once the deviation indicator comes a bit closer to the airplane symbol, I will hit view or localizer to capture the radio. Okay, we'll try and see what happens now. Yeah. Sometimes... Okay, I shouldn't... Yeah. You notice now, ideally, the aircraft should be continuing and then make a left turn to intercept. This Concorde and several other aircrafts within FSX, I'm not sure if it's a simulation limit or something like that, but it always tend to fly into the you know, to give a more of an intercept angle and then make a left turn. I would like the aircraft to make a, you know, gentle left turn to intercept the localizer. Well, that's how it is at least. I will now reduce my vertical speed so I won't bust the speed limit here. Usually I ask the ATC for high speed approved, and 90% of the times they approve it, but when they do have traffic, of course it's a bit problematic for them to do so. I will just do a swift stop here. Aha, it's tower online now. Thanks for the heads up. I will then check the ATIS. No, they don't have an ATIS. Okay. There we have an aircraft. Brilliant. This is what I love about VATSIM. There is always traffic. There we have one chap. flying along. Don't know where he's going, but yeah. Anyhow, I should notify the cabin now. Turn on my taxi turn lights. Actually, I will turn off the auto throttle just briefly. To reduce my speed a bit quicker. Once we get to 270 knots, I'll lower my nose and visor down to 5 degrees. And continue my descent. There we go. Setting indicated airspeed acquired again. Use acquired. Minutes talking, so it's okay. Good evening, Morgabeers. I'm doing good. I'm doing good.
Altitude alert, 1000 to go.
How about you? Are you okay? You're just perfect timing for landing here. So brilliant time. Check with the tower and see which. There we have an ATIS at least. If it says arrival 27 left, that's fine. Otherwise I will. Oh, fuck. I need to sort out the language. I need to have a quick word with tower and see whether it's okay to be landing 27 left.
Weather 3 Golf departure, Squawking 6467, Shuttle 2 Romeo.
Shuttle 2 Romeo, reverb right.
Heathrow Tower, good evening from Speedway Concorde forward, just overhead Ock, and we just want to see if it's okay for you to be landing on 27 left tonight.
Speedway Concorde for Heathrow Tower, hello, negative 27 right for arrival.
Okay, 27 right, Speedway Concorde forward. Alright. He wasn't maybe in the best of moods, anyhow. I shall be landing on 27 right then. Bit high on the speed, but well, it's okay. Then I need to have a look at 27 right then instead, because he didn't want to let me land on 27 left, but that's okay. It's not the end of the world. Same inbound course, and I've already set the minimum of 200 feet. Okay, we should have a look at the landing weight. We're currently weighing 103 tons, then I will count for 102 tons because it will burn a bit more fuel till we get to the final approach. So I'll set the speed bugs for 102 tons landing, which is 155.
Altitude alert, 1000 to go.
threshold target speed of 162. It's the threshold target speed is V reference speed plus 7 knots, so 155 plus 7 is 162. And the third bug I'm setting to V2 plus, sorry, V reference plus 20 then, so that will be 175. And the fourth bug I just leave as is. Left turn now, 360 degrees. Continue descent to 3,000 feet now. Nice effects here on the clouds, I must say. Looks beautiful. Classic London weather, I guess. Reducing now 190 knots. Turning now left 300 degrees to intercept the localizer. What weather engine are you running? I'm using Active Sky Next. However, I think it's the default clouds. I'm not sure. He ate the manual this morning for breakfast. Yeah. I've been trying to eating this Concorde manual for the last 3 or 4 years. I still haven't disabled the virtual flight engineer to manage the fuel, so you know, it's I mean, it's a fun aircraft to fly. It really is. This is the only aircraft I fly basically. I flew the 777 last night from Paris to Memphis, and that was a most boring flight in a long time, to be honest. Anyhow, I will be a bit off now. Heathrow Tower, good evening again. Speedway Concorde 4 established 27 right. Not really established, but almost.
Speedway Concorde 4, hello, 27 right, clear to land, surface wind 22 degrees, 13 knots.
27 right, clear to land, Speedway Concorde 4. Okay, we're clear to land, landing lights on, check the brake pressure, looks good. And we have 4 green on the landing gears, and the nose is visor and down. The nose and visor is down to 12.5 degrees.
Romeo, ready for
I can't see the runway, but yeah.
Shuttle 2 Romeo, taxi Alpha, hold at Lowman.
Taxi Alpha, hold Lowman, Shuttle 2 Romeo.
Right, I will set the missed approach track here to 318.
Radio altimeters are active.
There you can just barely see the landing lights. Actually, it's a bit messy on the final here. It's quite windy. Sterile flight deck now. Yeah, well, I will try. bit, you know, a bit bumpy today, apparently. Once we get to 800 feet, I will reduce my auto throttle speed to 162 knots, which will be my threshold target.
1,000 feet radio.
Slightly to the right.
.800 feet. .500 feet.
Stable.
400 feet. 300 feet.
100 to go.
200 feet.
Decide.
Continue.
100 feet. 50, 40, 30, 20, 15.
Stick forward. Reverse is on. Put some braking as well.
100 knots.
Try to
75
make
knots.
60 knots. There we go, made it there.
50. 40.
Turn on the brake fans now.
20 knots.
Speed of Concorde 4 vacated 27 left. Request taxi to Terminal 4.
Before Markus Völter taxi, right Alpha, left Echo, hold Echo 1.
Right Alpha, Echo, hold Echo 1, speed of Concorde 4. So seldom I land on the northerly runway. I need to pull out my taxi charts here. Yeah, Alpha is the northerly taxiway. I should make a right turn here, yeah. Right, and then hold, oh right, hold Echo 1, and that's just the southern part of Terminal 3 then. Okay, good. Anyhow, welcome to London Heathrow, and as you can see now the frames are really shitty and it's laggy, but hey, that's Heathrow, and we also have some weather upon that, so that's why. Did British Airways not take the Concorde out of service after that? No, they did not. They were very, what do you call it, resilient or stubborn, which I'm very glad that they were, because they got the Concorde back up and flying and did quite a lot of money from it. I will send you a link from an interview of John Hutchinson, where he explains about this crash and what happened afterwards, all that kind of things. Really interesting, anyhow. So we landed after 3 hours and let's say 20 minutes then. Okay, I'll need to have a look at the charts. Okay, Echo is to the left here, right?
Visual 2 Romeo, taxi Alpha, hold November 2 Echo.
Oops.
Visual 2 Romeo, taxi Alpha, hold November 2 Echo.
Hold November 2 Echo, shuttle 2 Romeo.
Yeah, 3 hours is pretty, just over 3 hours is pretty typical when you're flying from London to Kennedy and back. The quickest flight was done actually by this airframe, Golf Alpha Delta. Don't remember the year, but it was done in 2 hours and 50 minutes, something like that. They had a really nice tailwind at high flight levels. And they also call the ATCs on both sides to say we are going for the Guinness World Record. Would you please be so kind to help us a bit on that? So they didn't experience any delay or whatsoever, and I think their speed restriction after departure at New York was also lifted, so they could maintain VMO just basically after departure, no restriction below flight level 100. And of course into Heathrow, I think they landed on the easterly runways also. So they had
Visual 2 Romeo from November 2 Echo, 27 left, clear for takeoff, surface wind 220 degrees, 13
yeah,
knots.
2 hours and 52 minutes is pretty good. 2 hours and 50 minutes.
Right, November 2 Echo, clear for takeoff, runway 27 left, shuttle 2 Romeo.
What does the cruise look like with a Concorde at its cruise of like 5? The thing with Concorde, it never like stays on a specific flight level. It's constantly something called super or max cruise or cruise climb, which means that the autopilot will continuously climb, theoretically climbing all the way through the cruise phase to maintain an optimum flight level, or so so the engines can be doing the most optimum economical way of flying, sort of. But the thing is, it will also always try to keep the maximum speed at all times. So if the speed drops, it will descend a bit as well, just to keep the speed going, so to say. One interesting feature that also John Hutchinson mentioned in the interview there is about the nose temperature. The limit at the nose is 127 degrees Celsius. So whenever the autopilot also got input from this temperature here, the total temperature, and that's the total temperature at the nose. Currently it's 20 degrees at the nose, but usually when you fly at Mach 2 it's around 110, 100 or 120 degrees Celsius at the nose. And what the autopilot will do, maybe it's more like the auto throttle that it's doing things. It will actually climb a bit to slow down, to make sure that it doesn't exceed 127 degrees, which is the maximum. Oh, there goes an Airbus of some kind, 3 or something. Here's Echo 1. So we have a Concorde 4 holding short Echo 1.
Super, forward taxi left Alpha, hold November 5 Whiskey.
Left Alpha, hold November 5 Whiskey, Concorde 4.
Shuffle 2 Romeo, no further ATC available, 1 Unicom 122, decimal 8, goodbye.
1 Unicom 122, decimal 8, Shuttle 2 Romeo, thank you.
And the reason why Concorde is just flying at Mach 2 is due to the fact of the temperature. I mean, the engines can make the Concorde fly even faster, but but it's limited to its temperature basically. Alright, let's see. So therefore Mach 2.04 I think is the maximum max speed, I think. Something like that. You usually tend to end up on a normal flight around Mach 2.02. So somewhere there is the maximum speed. Oh, this was one hell of a tedious taxiing. Ideally I would have been landing here on 27 left, just make a quick left turn and another right turn and be at Terminal 4. Now I need to taxi like a sightseeing all over Heathrow Airport. Well, that's life. I'm not paying for the fuel, at least that's good. Did I just taxi? No, I did not. I thought I had gone too far, but I think November 5 Whiskey is just here to the right. Show an exterior, of course I can. This is November 5, yeah.
David 4, cross 27 left at November 5 Whiskey.
Cross 27 left, November 5 Whiskey, Spiel Concorde 4. Okay, so now when we cross we should turn on the taxi lights again. Turn on the transponder. That's at least how Scandinavian Airlines is doing that. So I will do the same.
Heathrow Tower, good evening to Bird 146, Airbus 319, QNH 1009, now passing 4,000 feet, descending 2,500, about to intercept localized runway 27 right. Bird 146, Heathrow Tower, hello, 27 right, close to land, surface wind 2 knots.
There, this is quite a nice view.
Bird 146.
Quite hard to taxi from this view though. Oh, that's true. There we go. Right, enough of that. That transponder was off. Shiver Concorde 4 vacated 27 left.
David, Concorde 4, taxi left Sierra, right Victor, stand 424.
Left Sierra, right Victor, stand 424, Spiel Concorde 4. Alright, it's on the other side. That will do. Oops. Let's see if GSX have stand 424. Did. No, follow me. Great external model, yeah, it is. And the fact that it's Concorde model doesn't make things worse, at least. I mean, if they have done the A380, I mean, it sure looked good, but it's the A380 is a damn ugly plane.
Cedars 146, I will clear it length. Cedars 146, SMU, clear to length. 37 feet, clear to feet. Clear to length, runway 27 right, Cedars 146.
Nice, there are one, two, maybe this one is climbing, or is he landing? Can't really say. Is there two aircraft in front of us in the air? Yes, they are. This one is just about to land. Then we have another guy. I think it looks like he's going for 27 right. Actually, I don't know where the fuck he's going. Oh well, none of my business. Yeah, yeah. I mean, if you ever visit a real Concorde on display, you notice that the landing gear is pretty. You know, it really is very high up in the air when it's on its landing gears. As always with Concorde, you need to overshoot seen from the cockpit, since the nose gear is quite far back compared to the cockpit here, so you need to tend to overshoot because your landing gear is like somewhere in the back there.
Studios 146, runway located Alpha 10 Echo. Studios 146, welcome to Heathrow, taxi right Alpha, left Delta, and 546. Studios 146, again the taxi route please.
And it was quite unfortunate about the crash there.
Studios 146, welcome to Heathrow, taxi right Alpha, left Charlie, hold out, stand 546. Mercer to stand 7546, right Alpha and left on Charlie, Studios 146.
I don't think it does any, any big difference, since it's no weight here. I mean, the center of gravity is still behind the nose wheel. The center of gravity is somewhere around here. It would be worse if the center of gravity would here. Then it could be causing a bit of an issue, I think. Oops. I think I need to taxi in the external view here upon parking because it's very hard. I can turn off the taxi turn lights now. You also have to remember that within this area you can carry more than 90 tons of fuel. So I mean, compared to this section, this section in the front doesn't weigh too much if you compare to the rest of the aircraft. I mean, all the engines, all the 13 tanks, and all that sort of things. Okay, that will do. Yeah. Right.
Speedbird 146, we are sorry, it seems that we have missed our taxiway. Request turn left now on link 59 and continue via Bravo and Charlie 2. Speedbird 146, that's approved. Link 49 Alpha, question Bravo and Charlie from 546. Roger, taking to tank 546 and 59 Bravo Charlie.
Right, welcome to London Heathrow. I hope you enjoy the little flight here. And I hope I will see you soon again, I guess. I don't know when the next time I will be streaming. Hopefully soon, I guess. Till then, I just want to say thank you for watching and good night then. Good night.